Today I'm going to talk about organizing your models, organizing models in GoldSim. And the concepts that I'll be talking about follow along with our style guide, and that can be found in our Help Center, which I'm showing you here. If you scroll down, there's a button here for modeling tips. Click that, and then you'll see a category here called style recommendations. And the part that I will be covering is under the section called model organization. Although I'll be covering a couple of things that are not mentioned there, but that is a good start to for a refresher on the ideas I'll be covering here. Okay, so to start off, I'd like to talk about choosing appropriate elements. Just like any tool, you could use it for maybe the thing that it's not intended for. You could hammer a nail with a wrench, for example, just as you could use an element in GoldSim to do something that is probably not intended to be used for, when there's a different one that would be much more useful. And so I'll walk through some of these and give examples of when and how I might use them. The first one is the simplest. It's the data element shown here on the top left. And obviously, I think this is obvious. If you want to put a numeric value in, numeric or a Boolean value, then you would put it here in the data element. And really, it's best suited for your constant values that you might enter into the model. The important part here is that the data element allows you to expose its value in the user interface, so in our dashboards, for example, and also scenarios for scenario data. It has to be done through the data element. So as an example, let's say you're working in some other element, let's say a pool element. I'm just going to open that. Now, you could type a numeric value directly. There's nothing stopping you from entering a value directly into a field like this. But that's not something we recommend, because now that value is buried there and makes it less robust of a model, harder to work with and change in the future. So we recommend that any values that you're going to be entering, use the data element. You can also put expressions inside of a data element. So for example, instead of typing 12 meters, I could say 12 meters per day and multiply that by 1 year and make it an equation, and it still produces the value, and nothing's wrong with this. But it is bad form to put equations in the data element for the most part. There are a couple of exceptions, mainly that being that you have some values that you want to load into an array. And so a vector or matrix data element sometimes, but this is a pretty rare thing, could be used to reference multiple elements and kind of group them into an array by using a data element that's non-scalar. What I mean by that is a data element that doesn't just have one value, but instead it is a vector or matrix. And so that way you can kind of manually create a new array in your model. The expression element, personally, I feel tends to be overused just because it's so versatile and it's straightforward. It's really just like the expression field of a spreadsheet. You can type in any equation in here and link to any other output in your model. Just name the reference the element ID and type in your expression. You can put you can make the expression as long as you want. Put if statements in here and all kinds of stuff. However, my preference would be to try to reduce the number of very large, long, hard to read expressions in these elements, and try, if you can, to utilize other elements such as the selector and the sum, things like that, in which you can simplify your conditional statements, your if statements. But the most important thing is that when you look at a model and you see nothing but a whole bunch of expression elements, it is a little bit harder to visualize when you look at it. If you try to make sure that you always put your if statements in selectors, and I realize that there are some cases when maybe you can't, but I would say those are rare. I would say try to always use the selector element. It gives the reader the ability to kind of understand a little bit better, where are the control statements like that, and just makes it more readable. The time series, I wanted to bring up the time series because sometimes I see people using a time series when perhaps the lookup table might be better. The lookup table would be best when you have data that is time dependent, however cyclic. So for example, maybe seasonal data, maybe monthly evaporation rates or something like that repeat every year, something like that. I would say it'd probably be best to use a lookup table for that because it's really good at interpolation and and definitely good for something that you're repeatedly going back on over and over again. The time series, while it's true, you can use a thing called time shifting. You can also do lookup functions on a time series to do a similar thing, but I would say for the reader of the model, it's probably best to keep your cyclic seasonal data, that kind of thing, in lookup tables, and time series with values that are unique going forward in time, always to stick with time series in those cases. I would say that's 95% of the time that you'd want to do it that way, but sometimes it does make sense to use a lookup table or time series, vice versa, in various cases. The stochastic element, the reason I want to bring that up is just a reminder that sometimes when you're building a model, you're waiting for data, you're waiting for time series data to come in, and perhaps you want to just put a placeholder in the model. A stochastic is a really good option there because while it's not the correct data, you might have an approximate idea of the average over time or something, and so you could put that in. But also adding some randomness to your model, it does allow you to make sure that your model can handle a wide array of variability, just to make sure that it is robust, and that maybe you catch some outlier conditions that you might not have seen and need to build some other additional checks in the model to make sure that it can deal with variables that might go out of bounds or something like that. So it's a good way to explore the functions in your model, I would say. So starting off, building a new model using a stochastic could be very helpful, just as a placeholder sometimes before you get all of your data in. The next three elements over here, the pool and these two reservoir elements, I want to talk a little bit about because the pool is still a little bit new, particularly for those of you that are working on models that have been built years ago and you're still maintaining them. You might still see reservoir elements being used where pools might be a better option, and there's a reason for that, and I want to show a specific example to demonstrate why the pool is a better option than a reservoir element. So those of you that are new to the pool, just a quick reminder that what the pool does is exactly the same thing as a reservoir, except that it allows you to bring in or link all of the inflows into a list. And then it also allows you, more importantly, to allocate the outflows. And so you can simply just link to the outflows instead of always requiring to use an allocator outside of the reservoir in order to prioritize your outflows from, if you have multiple outflows from a reservoir. Because of these differences, I would recommend that if you're ever simulating a pond, any kind of store, a pond, even a pile of material, it could be quantities of some material, or pond, tank, reservoir, anything like that, that you would use the pool element. And the reason we still call the old element the reservoir is because we can't change the name because of preserving older models that people are still trying to use. So we went with the new name of pool for the new element. But for the reservoir, I would say the times you'd still want to use that is maybe if you have a non-scalar representation of a reservoir or store, because the pool element can only be scalar. And the other reason you might use a reservoir element is if you're trying to simulate something that has nothing to do with a store, but has bounds on it. So, for example, you might have a valve that you're modeling how far open a valve is, or a gate, or something like that, and you need it to have strict bounds at fully open and fully closed. And so you might the units of this element might be something like percent to represent percent open. I'm just going to change something here, just make this scalar, make this simpler. Well, now I have to delete all these things, but anyway, so you might have a model that's simulating how far open a gate or valve is, and over time you want to find out exactly when it's fully open and exactly when it's fully closed. And so you might have an upper and lower bound of something like this, and then you would have expressions in here that would be calculating how fast the thing is opening and how fast it closes. But the nice thing is that it has bounds, so that you can easily make use of the way that GoldSim handles bounds, and you don't need extra logic to make sure that you calculate the time when it stops opening, for example, that kind of thing. That's a little bit more detailed, but those are the times I can see often using the old reservoir element. But let me now show you an example of that compares the reservoir and the pool element. And I don't know if this model runs necessarily, but I just want to show you an example here. So here's the new pool element, and this is actually a model in our library that you can go look at. But essentially what it does is, well, I've changed it a little bit to give it some more outflows just to make a point. But we have two inflows coming into this reservoir. And I'm just going to call this pond so we don't confuse ourselves with the name of the elements. But we have two inflows coming into this pond. And then the way that works in the pool is in the inflows tab, you just list them here. And so they're all summed up. The nice thing about this is that now it has a secondary output called total inflow that you can reference. So it's nice that it allows a place to add all of those flows up, but also nice that you can report on what the total inflow is very easily. You might have multiple outflows on a pond. That's pretty common. And in this case, we do. We have two different ones. We have an outflow that is called pumping. It's just got some logic in here that, whoops, I need to move these up. It has some logic in here that essentially turns on and off using a status. Status is, by the way, the best way to control flows that are turning on and off from a pond. And we do have a model example that shows this, but we are coming up with now a request to remove water from the pond using a pump, and it turns on and off depending on the water level, actually depending on the volume. And then we have some loss that's just a function of the volume. So it's just based on a unit rate of some percent per day, over time is loss. So you just multiply this percent per day, multiply that by the amount in the pond, and then we can calculate a small loss. So in the pool element, if you go to the outflows tab, then you will see that we have these two priority discharges here, these two requests being made. And then we just simply link to all of the outflows on this pond element. So I've got the requests being calculated here, and then I have the actual outflows being referenced here. And they're just simply a secondary output of the pool, as you can see in the outflows folder. Okay, so what does this have to do with model organization? Well, the reason I'm bringing this up is just because it's important to consider if you have an older model and you're looking at upgrading it, it does actually help with model organization to convert your old reservoir elements to pool elements. Let me show the same exact model in using the reservoir. So this is the old reservoir element, and we've got the same model, but what it requires here is that you reference things twice, and there's room for making human errors here. So what do I mean by that? First of all, what we have to do in here is we have to add up all of the inflows manually. And you could, I mean, you could miss something here, you could type something wrong, but also you can't ever reference the total inflow. There's no way to know what the total inflow is unless we put a new element outside where we add them first and then put them in here. Also on the outflow, we don't know what the total request is. We can't access the total request. We can only access the total withdrawal that occurs. And so if we wanted to see what the total request was, we would have to sum them up outside of this element. Otherwise, you're adding them all up in here. But the challenge here is to make sure that in addition to that, that you put an allocator element in which you again refer to the same requests as demands, and then you refer to the total withdrawal rate from the pond, and then the result then comes out here as the rates. So there's all these additional steps, and it adds additional clutter and confusion. And so it's important to consider using the pool element when organizing your models. Okay, so let me go back to previous example here. Okay, so I already talked about you trying to use this selector element. If you notice you're starting to type if statements in an expression, it's true that it's very simple to do, especially if it's just doesn't have any nested if statements. However, it makes the model more readable if you use a selector to do the same if statement. Same thing with the sum. You can add elements in an expression element. However, it makes the model much more clear to show that you're adding a bunch of values together using a sum element. The status, like I mentioned, is good for when you want to change states, but for example, in a switch, when you want to switch something on and off, but you want to keep it off for a delayed amount of time, and we've referred to this many times in previous webinars. If you have a dead band around control for holding a temperature in the room or holding a water level in a pond, that kind of thing, you want to use a status element because it carries state forward and allows you to hold a state until you reach another point at which you want to allow it a delayed response so that you don't oscillate. Whereas if you're using a selector element to try to do the same thing, such as if water level is below some number, then turn it on, otherwise turn it off, then you're going to significantly increase the possibility of it oscillating and slowing your model down. And in particular, when you have you'll have serious issues with this if you are inserting unscheduled steps in your model, and that would happen at the bounds, the upper and lower bounds of your reservoirs. And this is a very common occurrence that I see in models in which people are using selector elements to control discharges or inflows to a pond or tank. And so if you see that in a model, if you see a selector element, I would immediately question that and see if this can be done with the status. And it would, in a lot of cases, improve the model. Okay, I also wanted to talk about the triggered event, and the reason I'm calling this global trigger is because I just wanted to mention how a lot of times you're defining many triggers in your model throughout the model. Cases might be discrete changes or stochastic elements, and when you define the triggering, let me just open up the stochastic to show an example. If I were to define the triggering mechanism for the stochastic, to tell it when to resample a new random number, then what you'll see is it says on changed eDay. This is a common one. You know, if we have a one-day time step, this would be a common way to trigger. And it's fine to put this here. However, there could be some situations where in the future you might decide that you want to trigger some of these in a different way. And so having the trigger at a global location can be very useful, because if you ever want to go back and change that, you would just change it in the one place instead of having to go through your model and change all of these triggers. So then instead you just be referring to the event element itself like that, and do that throughout the model. And that makes it easier to maintain going forward if you ever need to make changes to that trigger. Okay, and lastly, the use of previous value versus a delay. So as you might have found in some models where you are simulating a system of flows being passed around into a system, maybe you have recycle flows, something like that, and you've maybe found that you hit a recursive loop when you do that. A way to break the recursive loop is to use a previous value element, right? So, and the reason for that is because it's not referring to the immediate value, it's referring to the one on the previous time step, thus breaking the recursive loop. And so while that does work, you just have to keep in mind that the previous value element is, you can't think of it as, well, it's delaying everything by 1 day because I have a 1 day time step. That's not necessarily true. It's delaying the value by the it's just essentially giving you the value in the previous time step, which could have been an inserted time step. So it could be reporting to you the value that happened 5 minutes ago instead of 1 day ago. And sometimes that comes as a surprise to people. And so if you're trying to break a recursive loop, then I would highly recommend that you change those out with the material delay. Okay, so with that being said, it's just important to keep in mind that you're choosing the correct element for the job. Okay, so now I want to show a sample model to talk more about organizing. Okay, so this model is pretty simple, but it's a flow model. I wanted to show a flow model because a lot of you are working on those kinds of models, and it's important to organize them in a way to show how the system works. I mean, that's the reason why GoldSim has these graphical elements and the influence lines, so that you can show how the objects interact. It's very important. And in some cases, because of how the different components are referring to other outputs in the model, you get influence line overload to the point where you've got so many influence lines moving around that it doesn't really provide any value as far as a schematic diagram of the system. And so I talk about this an approach to help make the schematic diagram better visually represent the flows in the system. I propose and talk about this methodology that if you hold to it when you build the model, that it will better show you a visual representation of the flows in a system. And I'm talking specifically right now about a water balance model, flows moving through a system. And it doesn't mean that it's only applicable to that kind of a system. It could be applicable to a lot of different kinds of systems. But here's what I want to show. This is a model that demonstrates it. Before I go into that kind of methodology, I want to talk about a few other things. First of all, just the layout and how we are setting up the graphics pane of each of the containers in your model. Now, I am working with a higher zoom scale, a Windows zoom scale. So what I mean by that is if you in Windows 10 anyway, if you go to Windows settings and then go to your display and you look at your scale, you can see I'm using a very large scale here, and I'm doing that on purpose because of doing a presentation. I want to make sure everybody can see this and not make it too hard for people to read. So I would say in a lot of cases where I'm not doing a presentation, I would be looking at this at probably a little bit smaller scale, probably a zoom of a 200 or maybe 150 or something. And by the way, this is a high resolution screen, so if you're not working on a high resolution screen, you probably wouldn't ever adjust that. But on newer screens, this is the case. But anyway, I just wanted to mention that because it kind of limits the number of elements, obviously, that I can show on the screen right here, right? So maybe on your screen you can show quite a few more, but just keep in mind that if you plan to distribute your model to people that might have, they might not have the same resolution on their screen as you, they might have a size more like mine, then just kind of keep that in mind. It might be harder for them to read when they load your model. But one thing I would suggest is to try, if you can, to stick with our defaults. Because sometimes what I find is that people start adding more and more elements, and then they just realize they're running out of space, so they just zoom out. And a common zoom is 75% within GoldSim. Here's 70%. And maybe this is still pretty easy to read, but it is getting a little bit harder. And the problem with doing this is, you might have a paragraph of text that's getting harder to read. And so sometimes what I've seen is that people change the font size. And so when you start doing that, so for example, if I just take this, I could make this much larger and then say, okay, well, now it's easy to read. Well, now I've got to move stuff. And now I've also got to, whenever I add new text, for example, if I just click on the text icon and I add new text, well, it's always coming in, at this size. Now I've got to change it. And I realize that you can change defaults and so forth, but there's still other things that you won't. You'll have to constantly be modifying things as you work on the model, right? You're going to have to change the text size of your labels, and it just goes on, and it's just creating more work as you go forward. So my recommendation is that you keep defaults if you can and stay with 100%. And if you're worried that, well, I can't fit everything on here, it might be a good time to ask, should I be showing all of the elements on this page if I can't show them at 100% zoom without forcing the user to zoom out or scroll around? And I would say, maybe it's better to organize it in a way that groups it better. However, the one exception to that is when you have a large schematic flow diagram where you want to show the entire system. And yeah, that does happen, but that would probably be the only container that would have a different zoom. And it would be good to keep all of the other places a default. It's definitely helpful there. By the way, I just want to make sure everybody can hear me okay. I haven't heard any complaints or seen any questions, so I just want to make sure that everybody can hear me. Looks like we're good. All right. The next thing I want to talk about is, and you probably also noticed that I have labels on the influence lines. That can be done by simply coming over until your cursor is on the influence, right-clicking and selecting Add Label. The other thing I wanted to mention is the container, and you'll see here how all these containers look like they're closed, and there's a purpose for that. I've seen models, quite a few models, where the containers are still global, they're open, and that is a bit concerning, especially when you're trying to represent components of a system like this. These containers represent physical components, they're objects, and when you have that condition, you definitely want to be using localized containers, and I'll explain that in a second. Over here in the browser, you can see that it shows us the difference between the global and the localized containers. Global being the white and the globalized or the localized being the yellow ones there. But the nice thing about having localized containers is that on the inside of the container, the elements can be local. They're the naming conventions that you're using inside of the container. They don't need to continuously refer to the object itself. And so what I mean by that is that it can be generic naming conventions inside of the container. Let me go inside of this one that says pond1 right here. So I'll go in there, and you'll see that it says things like evaporation, pond capacity. It doesn't say anything about it being pond1 necessarily. There are a couple of exceptions in here, of course, but for the most part, we can keep the names of things fairly generic. Delivery, overflow, and that's why it's important to put a title at the top of your graphics pane in the container. Put a title that's bold and probably size 16, something like that, so that when someone goes in here, they immediately see, okay, this is where I'm at. It also says it up here in the address bar, of course, but having the title up here is helpful. Trying to have that title in every single container. I know it's it could be a bit of work because you have so many containers possibly, but it does help to always put that up there. It's not as straight. It's not as glaring, as seeing it appear in the address. And so, seeing the title up here is important as you look at these generic names, and you're trying to read this model. You're always being reminded, okay, we are in pond1. If I had these containers open, if these were globalized containers, then I would have to give them names that are specific to pond1 everywhere. I'd have to say evaporation _ pond1, overflow _ pond1 to keep them unique and to prevent conflicts with other names in the model. The other nice thing about the localized container is now we have exposed outputs that are like attributes on an object. So if you're familiar with object-oriented programming, then you'll know that when you create an instance of a class and create an object that has attributes to it, and you refer to those attributes with the dot notation, the same thing can be done here. And let me just review. If you go to the properties of the container, let's move this over, then you'll see there's a tab here called exposed outputs, and that's what's available when you localize the container. And then you can see the list of all of essentially the attributes of this container, of this object. And now what that allows me to do is I can come over, let's say I wanted to go somewhere else and refer to something from pond1. I'm just going to refer to a flow rate in there. Just changing that to a flow rate. So now all I have to do is just start typing pond1. There it is, tab. Then I just hit dot, and then it shows me a list of all of these exposed outputs immediately, making it very easy to work with it, just as if it is a true object in the model. So that's really important for organizing your model, making sure that when you are in the container that is showing physical objects, representations of physical objects, that you have localized containers in cases like this. Okay. The next thing I actually heard from a user recently, and it's a good idea, is that it's often helpful to curve your influence lines if you have a lot of them. It makes it just visually, it's easier to see how the influences are linking if you try to curve the lines like I've done here. It just, for whatever reason, it's just easier to look at than if they were straight. So as a review, just to know, so that if you didn't know, to put the curve, you click on the influence line until you see the little blue dot, and then you can move it, right, to make it curve. Okay. All right. So now what I want to do is talk about this methodology of organizing a flow system. It requires that you have to be pretty diligent when you're building the model. And unfortunately, if it's an existing complex model with many influences and elements, it's a time-consuming project, unfortunately, to change to the methodology I'm talking about. But if you're building a new model, then it will work very smoothly, and it shouldn't be it shouldn't be adding more time than usual to the process of building the model. Now, I should say though that you can convert an existing model to this methodology. It is possible. I've done it before, but it would be best if you had a good understanding of that model before you attempt it, because it does require reorganizing some things in there. And if you don't understand the model, yeah, it's just not going to work well. You know, I can't do it well if I don't understand the model. I'm not going to be able to do it either. So anyway, what I would say, however, is if you have organized a model this way, I think for other users that are coming at it fresh, it will be much easier for them to read it. Okay, what I want to do first is I want to show you what this model, this same exact model, what it will look like without doing that approach. Okay, so let me go back and see if this is the one. It is, okay. And real quick, I need to, well, I can point it out and then change the colors. You'll see we have these additional influence lines, the green and the 2 red lines here. That's all that's different in this version of the model. Some of the elements might be in a slightly different location, but it's the same exact model. It's just those 3 lines are showing up. Okay, so how did I get those lines to disappear? I didn't just turn them white. I didn't just delete them. They still exist. They still occur. But it's really important to differentiate what these lines represent from the others. And that's why I've color-coded them. But I'm not a real big fan, to be honest, of changing the colors of influence lines because there already is a color scheme that's used for coloring these lines for the different types of outputs. And I like to see those different types. But anyway, it's not a problem if you do it. It's just something you'd have to, you know, again, it's something you'd have to manually do and to be diligent about. But anyway, these red lines and this green line, these are not water flows. The black lines, those are all water flows. And so in a more complex model, if you can just imagine for a second of many black lines, I'm just going to reset the default style and color for the influence lines. There we go. So just imagine many more of these black lines going all over the place. Okay, in a real model, that's what you're going to end up with, and it makes it more challenging to see where the water is flowing. And that's why we wanted to put these containers here in the first place. Is we want to show a schematic diagram of our system. We want to show how the water is moving around. And just to review with you what's happening in this model, we have a stream here going down the left side and a diversion point. At the diversion, we're moving water out of the river and over to this first pond. And then from here, if this pond fills up, it immediately overflows into pond 3. And then if the pond gets low, then we'll pump water back from 3 over to here. And then the next thing we do is we're sitting over here at pond 2 and we're saying, hey, we need to deliver water to A and B down here. And if I get empty, I need to go ask pond 1 for some water. And so there's this talking going back and forth, people talking to each other, essentially, is like what it's doing, right? And then over here, in addition to that, this demand A has to contribute to the calculation over at the diversion to say, hey, we need water to be diverted into this pond so that eventually it can come over to us. So it's really a communication line there, if you were to think about it as types of lines. And so what I like to propose is that because a lot of these models, the whole purpose of them is to do a water mass balance, I feel it is very important that we show visually the water flows and the mass balance visually. And what that means we need to do is isolate, not remove, but we need to isolate the communication lines and put them in a different place. And what I mean by that is I reference all of my communications like this. I call them information references. I reference them in a upper level, in a parent level above the point we are at here. So let's just say for an example, in this particular one, this particular line that I'm looking at right here, this one right here is called A priority. It has an R because it references it. Anyway, don't worry about the R, but it's the priority for this demand. It's being referenced over here in pond 2. And so if I go in here to pond 2, then whoops, I'm going to move this over here. Let me see if I can go down. Okay, so over here I have priority A being referenced, and if I go into the pool element in the outflows, you'll see that the priority is being referenced here to calculate a flow that goes to demand A. All right, so my suggestion here is that instead of just linking immediately from A to pond 2, is instead to reference it up. So if I go up a level, I'm going to hit the go up, and now I'm looking above at one level. Here's the system model. We were just inside of this. What I'm suggesting is you reference the priority A out here. I'll just put that there. And I already have a name, priority A. I'm just gonna put underscores at the end for now. I'll show you more about how to give it a better name. But this is just for demonstration. So now I'll go into A and get its priority. Okay, so now that's out here, and now I can go back over to pond 2. Instead of referring to the priority from A, I'm going to go all the way to the upper level of the model and refer to that reference that I made. And now you see that the influence is gone. It's important to note, however, that we haven't necessarily made the model 100% more foolproof here. We're still making a reference that went to a different place and now came back to here. But in my opinion, if you're able to be consistent with the way that you're naming and referencing these outputs, that it can still be quite clear to the end user. And importantly, however, is that we are showing just the flows now. Okay, so let me go back to the model in which I've gone through the whole process, built up the entire model with all of those references being moved. Now here we see only flows. This is only where the flows are going. And so what I've done, if I go up one level, is I have the system model here, and then I have information references here. So I put all of my communication references in here, and the priority is located here, and I put an underscore R to in all of the elements, all of these references that will be located in this container. I put underscore R, and the reason I do that is because it flags it so that when you're reading a model, when you're down inside the into the details of your model, and you see a reference to something underscore R, then you know this is okay. This is one of the things that's communicating from another place, and so they're held here, and then they're brought back in. So you can see there's the feedback going back and forth, and then it clears up and brings to us the view only of the flows. And where this really helps a lot to be able to come in here and see where these flows are going is when you're doing a mass balance accounting. When you want to make sure that all the inflows minus the outflows minus the change in storage equals 0, it is much easier to make those, to set up those calculations when you can come back over to here and you can look at this and say, okay, here's where all the flows are going. One thing you kind of need to think about, however, is things that are going to a global sink or coming from a global source. So an example is precipitation and evaporation. You might have a situation where you've got all kinds of elements in here, or sorry, all kinds of objects such as ponds that are all evaporating to the same place, to the sky, right? And so what does that mean? Does that mean you have an object in here that's called sky or atmosphere, and they're all pointing to it, because that's going to clutter, this page as well. And in those cases, what I found is useful is to have a sink and a source, for that type of thing out here. I might put another container here that's called, evaporation, or maybe atmosphere, or I don't know, some place, or a sink where all of those things can be pointing to, and thus greatly simplify this part of the model. Usually those values are not the significant driver in the system anyway, but it is important, obviously, to account for them. But having a specified place for them does help, by the way, making sure that it does help to make sure you account for all of them if you have more of a global container for them all to be referenced in. Also, keep in mind that when you see the dot in these output ports, that indicates that an output is being sent outside of the view that we are in. So you will see those more often if you're using this approach, because you're sending these references outside. So for example, pond 2 is sending a reference outside to my information references to say, I need to tell pond 1 that I'm empty and I need water. And so that's the communication that comes back into pond 1. You can see it has a dot on the input side telling it that, hey, there's something coming from the outside coming in. So if you would like to see this example model, let me know and I can point you to it, and you can see how this is set up. But you can also see how to do this in our section called Model Organization under our Style Recommendations right there, and it will walk through the whole process. And I think it also includes an example in there. So highly recommended. It's been useful for me. I've built a couple of pretty complex water balance models using this approach, and I feel it saved a lot of time. So, but with that, I'd like to end there, and I'm happy to take any questions if you have any at this time. Okay, so the question was about good best practices for pasting background images into your model. I want to talk about that actually, and I know we're out of time, but it's important. We do have an article, and I can go search for it, but I just want to say, just keep in mind there are two types of images: vector drawings and raster images. Raster images are the ones that are pixelated. That's what you'd find with an aerial photograph, for example. An aerial photograph is one of the few, okay, there might be an excerpt from a journal, or showing equations or something. Well, you could still write those equations in like a PowerPoint or Word document using the equation writer, and you can save those as vector drawings. If you can go vector drawing, that is far and away the best, way better for inserting graphics into GoldSim, if you can get it into a vector drawing. And PowerPoint is, I think, the easiest way to get a good vector drawing that is in the right format. And so I'm sure all of you have PowerPoint. If you're using GoldSim, you have Microsoft Office, I'm sure. So PowerPoint is by far the easiest and most convenient, I think, way to get drawings into GoldSim or get any kind of graphic, except for aerial photographs that have to be raster. Okay, so let me explain. The best way to get let's start with raster images. So aerial photographs. I would do that by, I'd probably put that into PowerPoint too, and then just copy and paste it into GoldSim. But you don't have to. You just make it in. I would say JPEG is great. Just use JPEG and put it in. It's going to add to your file size overall because it's safe with the model. So that's just something to keep in mind. Just don't make it bigger than it needs to be. There's no reason to have high resolution, aerial photograph inside your model. It just unnecessarily bloats your model file. So JPEG is good. It compresses well, so I would say JPEG for that. Okay, so that's raster. If you're inserting a logo for your company, or I don't know, like I said, equations, or any kind of drawing, try to get it in the vector format, and your graphics department can always get it for you that way. But here's the important part. It needs to come in as an EMF. It needs to be an EMF type. That's a file type called EMF. However, unfortunately, there's an old library that Microsoft used to use for rendering EMF that does not render well. It looks kind of jagged, and you need to make sure you're using the newer version. And you can always 100% always use it. Use the right one if you bring it out of PowerPoint. However, there's one thing you need to make sure you do, and if you're curious, I can send you the article about it. In fact, let me just do a search. It's really important. So let me see if I can find it in here. Okay, I'm pretty sure it's this one here called File Formats of Images Inserted into GoldSim. I think it goes through and talks about, yeah, it talks about those differences, how they'll look different, and how to paste them and so forth. But without boring you with all the details, let me just show you what I do. Okay, so let's say I have a blank presentation here, okay, and I want to insert my logo. Okay, so I'm just going to go get it from my, hold on one second. I have to go to my logos. One second. You're going to have to bear with me here. Okay, so I have our logos saved in different formats. I have the original vectors that our graphics people developed, and their SVG and so forth. I can't use that. Well, I could, but I'd need different software. But I have these EMF exports I've already created, and then I have raster, and rasters are good for if I need to put it in in some other thing. But for GoldSim, I go to EMF. And if you don't have an EMF already, you can convert it to EMF. You can have your graphics people convert it to EMF, or you can use Inkscape. It's a free software, and that'll convert it to EMF. But if you don't have, well, no, those are the ways. Those are the ways you can do it. I think you can also load an SVG into PowerPoint and convert it to EMF, I think. But anyway, so I'm just going to put the logo in here. So here's the logo. So this is an EMF drawing. And just to make sure that it's going to use the latest library, I always go here to ungroup, and it will always tell me, do you want to convert it to a Microsoft Office drawing object? And I say yes. And when you do that, it will become the format that you need. I mean, in my case, it already was, but just to make sure that it is, then you can do that. Sometimes you have to turn off outlines. Sometimes it automatically outlines things. You'll have to see. But anyway, doing that process in PowerPoint is what will make it the right format. So then I just need to save it as a picture, and then you just select in here the type. You select EMF. Make sure that it's EMF. And once that's EMF, then, gosh, it's so small. Okay. Then I'll go put that on my computer. So I save that there. And then what I can do, of course, is load that in using the insert image command. There's the EMF. And there it is. The nice thing about the vector drawing is it doesn't matter how big the drawing is, it's the same size. So it always looks great. And then you probably want to lock the aspect ratio if you're going to resize it. So I'll do that. And then, as you can see, it always looks great. It always looks perfect, actually. That's how your images will be. And the file size, by the way, let's look at the file size. So the file size is 7 kilobytes. So pretty small. And I can make this any size, and it looks great at any size. And it's always 7 kilobytes. So that's definitely the way to go. I hope that answers your question. But yeah, like I said, we talk about that in that article, so you can look at it. All right. Are there any other questions? All right. It looks like we don't have any more questions, so I'll go ahead and close this, and we look forward to seeing you next month. And also, if you have any follow-up questions afterward, you can always contact us later on. Thanks for joining. Talk to you later.